All right, Mr. Ahmed here for 3.1. We are going to work with angle pairs that are created by lines and transversals. So the new term here is going to be transversals, and we are going to create some angles with a transversal. A couple definitions first. First one you've probably seen before, that's parallel lines. Parallel lines are two lines that do not intersect and are in the same plane. So they are coplanar. So a couple things on the parallel lines there, indicated by arrows on the line. So you'll see the line and then also a set of little arrows as well. Those two little arrows on that line indicates parallel. The symbol for parallel is two lines going up and down. So I could say line L is parallel to line M. The first thing we're going to do on our first example is just identify some parallel lines and some perpendicular lines. Keep in mind perpendiculars intersect to form a right angle. So the first one says parallel. So I'm looking in the diagram, parallel. Well, these look like it, but this one's got the arrow mark and so does this one. Since these two lines are marked with the arrows, that means those two are parallel. I do not have a little letter to name them, so I have to name them the hard way, 2 points. So line EF, line sign above it. EF is parallel to line, our other one is named GH. So those two are parallel. Now we're looking for a pair of perpendiculars. So there's my right angle, the box is marked. So the line going up and down, BK, is perpendicular. Upside down T is the symbol for perpendicular. And that's perpendicular to the top line right here at this right angle, AC. And then it says name a pair of lines that are appearing to be parallel, but we aren't able to tell for sure. So I would say that it looks like AC is parallel to EF, but since there's no arrow marked on here, I can't say that for sure. So AC, line AC, and line EF look to be parallel, but we aren't able to say that. And finally it asks, is CG parallel to KF? So CG is here, KF is here. Well, they look like they're not going to intersect, but there's no arrow marking, so it's undetermined. No markings. So we have to really look for those markings to ensure that they're parallel or not. Our next definition is going to be a transversal. A transversal is a line that intersects two or more lines at different points. So in this case, line T is our transversal because it intersects two lines at different points. Now here's the key. Since this thing intersects here, when we have two lines and a transversal, 8 angles are formed, all right? With these angles, I'm going to refer to the groups of 4 as clusters. So angles 1, 2, 3, and 4 make their own cluster. And angles 5, 6, 7, and 8 make another cluster. So they're connected to each other. So I'm calling it a cluster. So we have the red cluster on top, the purple cluster down on the bottom. So 4 angles per cluster. When any two lines intersect, there's always 4 angles. Okay? Any two lines that intersect always create 4 angles. Now inside of these clusters, there are going to be specific relationships for the angles, and that is what we are going to work on next. The first 2 terms should be a review, all right? And the first one we're going to talk about is supplementary angles. And when we're talking about ones we can assume for sure are supplementary, typically we are going to look for a linear pair. So here is going to be my transversal T, and then 2 lines intersecting it here and here. Okay, I'm going to draw every diagram like that. Angles 1, 2, 3, and 4, 5, 6, 7, and 8. So a linear pair, 1 and 2, those are supplementary. They're in the same cluster. Another linear pair could be 7 and 8. All right, those are linear pairs. The next example involves vertical angles. I'm going to highlight these a little bit. Angle 1 and 2, 7 and 8. There's obviously more examples than that. Those are just the 2 that I chose. Vertical angles. Same thing, those are in the same cluster. All right, so I'm going to draw this same exact diagram again. This time we'll draw it in a different color so it stands out a little bit more. So here's our transversal T. One line going through, another line going through. All right, angle 1, 2, 3, 4, 5, 6, 7, and 8. So when we look at vertical angles, keep in mind vertical angles make the X. They are congruent. So angle 1 and 4, that's one example. Angle 1, and since they're congruent, I'm going to mark it. Vertical angles are always congruent. Another pair could be 6 and 7. Those are vertical angles. Highlighted in blue, I chose angle 1 and 4 and angles 6 and 7. I'm going to do that in different colors. That way it's very obvious. Angle 6 and 7. Okay, so those are across from each other. They make that X. All right, now on to the new ones. These ones are going to be in different clusters. So one's going to be in the top cluster, one's in the bottom. We can also have clusters on the left and clusters on the right. So here we go. I'm drawing in my transversal T. First line, second line. All right, angle 1, 2, 3, 4, 5, 6, 7, 8. Corresponding angles are in the corresponding location of the cluster. So we're in different clusters and they're in corresponding locations in the cluster. So if I look at the top cluster and just choose angle 1. Angle 1 is on the top of the line and to the left of the transversal. So if I go down to the other cluster, for it to be on top of the line and the left of the transversal, that would be angle 5. So angle 1 and 5 are corresponding. Another example of corresponding angles, I'm going to choose this time angle 4. And 4 is on the bottom of the line and to the right of the transversal. So 8 would be in the corresponding location in the other cluster. Bottom of the line, right of the transversal. So 4 and 8 are considered to be corresponding. Okay, so those are my examples there. I'm going to put a comma here instead of an and sign. All right, alternate interior angles. Coming up next. So with our alternate interior angles, those are going to be in different clusters as well. So here's our transversal T, angle 1, 2, 3, 4, 5, 6, 7, 8. Alternate interior angles are in different clusters. They're both inside the two lines. So when I think inside of the two lines, here's my two lines. Inside would be like angles 3, 4, 5, and 6. Okay, those are all inside. They're on the interior. 1, 2, 7, and 8, those are on the outside. Those are exterior angles. So for them to be alternate interior, they're both inside, but on opposite sides of the transversal. So 3 is inside in the top cluster. We have to go to the bottom cluster. Inside, opposite side would be 6. So angles 3 and 6 are alternate interior angles. And another pair could be angle 4 and angle 5. All right, that's the other option. Angle 4 and angle 5. Those two are also alternate interior, both inside, opposite sides of the transversal. Alternate exterior angles are also going to be in different clusters, okay? So when I draw in my transversal again, T, here's my first line, and my second line going here. Angle 1, 2, 3, 4, 5, 6, 7, and 8 again. Exterior. So, different clusters on the exterior. Angle 2 is on the exterior, okay? Outside the line. Now I have to go to the other cluster and go to the opposite side of the transversal. That would be angle 7. 2 and 7 are alternate exterior. They're both outside the two lines, opposite sides of the transversal. So angle 2 and 7. And another pair of alternate exterior angles has to be angle 1 and 8. Angle 1 is outside. And then we go to the other cluster, opposite side of the transversal. That gets us to angle 8. 1 and 8, alternate exterior. All right. Last one, this is most commonly forgotten, most difficult one. It's in different clusters as well. And what we're going to have here is we're going to again have our transversal, T, first line, second line. I'm numbering the angles the same again. Angle 1, 2, 3, 4, 5, 6, 7, 8. So, same side interior also can be called consecutive interior. Same term, just named two different ways. And those both angles are inside of the two lines, but they're on the same side of the transversal. So they're in a different cluster. So angle 3 is inside, but if I say on the same side the transversal, the other angle that's inside is angle 5. So angle 3 and 5 are consecutive or same side interior. And there's one other pair, and that would be angle 4 and angle 6, both inside the lines, and they are on the same side of the transversal. Now, these terms need to be memorized. We need to memorize all these. We need to know supplementary, those are the linear pairs. We're gonna need to know the same vertical angles, corresponding, alternate interior, alternate exterior, and same side interior. Now for these, I will do a couple abbreviations, all right? Supplementary, I'll abbreviate SUP, okay? And I'll also say linear pair. Vertical angles, vert angles. Corresponding, C-O-R-R angles. Okay, alternate interior is going to be A-I-A. Alternate exterior, A-E-A. And same side interior could be S-S-I. We'll stick with the S-S-I. So you can abbreviate those in that manner as well. You'll see AIA, AEA quite a bit. All right, so hopping into our next example. The first thing we're going to do is we have, notice, our clusters of shift. Now we have a left and a right. Okay, that can happen as well, instead of just a top and a bottom. It's really the same process. You could even turn your paper if you want to envision it as a top and a bottom, but I don't think it'll be necessary. We're just going to talk about it a little bit differently. So, corresponding angles first. It says 3 pairs of corresponding angles. So here we go. Corresponding angles. If I chose angle 5, angle 5 is to the left in the cluster and on top. Corresponding location in the other cluster is to the left and on top. That would be angle 7. Okay. Another pair. I'm just choosing at random here. Angle 2. Angle 2 is bottom right in the cluster. Bottom right in the cluster is 4. So angle 2 and angle 4 are corresponding. One other pair, I'll take angle 6. Angle 6 is top right in the cluster. Angle 8 is also top right. Okay, that's all we got. Alternate exterior angles we'll do next. Then I'll go to alternate interior. I know I skipped, but alternate exterior. So outside the two lines, that's going to be to the left and to the right. Inside is angle 6, 2, 7, 3, 1, 5, 8, and 4 on the outside. So alternate exterior, angle 5. Opposite side in the other cluster is angle 4. So 5 and 4, alternate exterior. The other pair is angle 1. Whoops. And opposite side the transversal, other cluster is angle 8. So 1 and 8 are alternate exterior. There is not another pair, so I can't do it. There's only 2 pairs of alternate exterior angles in this diagram. Next step, we're looking for some alternate interior angles. Now we got to go to the inside. So angle 6. And opposite side, different cluster, also interior is angle 3. Other pair is angle 2 and 7. There is not another pair of alternate interiors. I can only list 2. Same side interior, this is the tougher one. Same side the transversal, inside the 2 lines, angle 6 and 7. And we also have angle 2 and angle 3. Those are also consecutive interior, same side interior. There's not another pair. Now vertical angles, keep in mind vertical angles, those are in the same cluster, across from each other. Angle 5 and 2. Vertical angles are congruent, so I'm going to state that they're congruent. Another pair would be 3 and 8. And 1 and 6. And now we're looking for supplementary angles. Linear pairs, keep in mind those add up to 180. Angles 5 and 6. 7 and 8. And 3 and 4. Those are the ones I chose. There's obviously some more. All right. Naming the angle pairs. What I'd like you to try and do is push pause here and give this a shot on your own. This shouldn't take long. Just say, are they corresponding, alternate interior, alternate exterior, and then turn the video back on and see how you did. All right, number 1. These are corresponding. They're both to the left of the transversal, and they're both above the line, so corresponding. Notice I abbreviated it. Number 2. Those are both to the right of the transversal and both below. They're in different clusters, corresponding locations. Those are corresponding angles. Number 3. Both to the right, both above, different clusters, also corresponding angles. Left, left, below, below, corresponding angles. So the first 4 were all corresponding. Let's see if that trend continues. Now I have angle 1 and 4. Those are in the same cluster. They are across from each other. Those are vertical angles. They are congruent. Angle 2 and 4, linear pair, supplementary. All right, now we have angles 2 and 8. Different clusters, both on the outside. Those are alternate exterior angles, AEA, alternate exterior angles, 2 and 8. And lastly, we have angles 3 and 6, interior, interior, alternate interior angles for 3 and 6. And lastly, these ones are a little bit tougher. If you have more than 2 clumps or 2 clusters, what we have going on here is we have to identify the transversal. So the first one, 11 and 15, 11, 15. So the transversal that's connecting 11, 15 is this bottom line. So I could eliminate the top part. That doesn't even matter. So 11 and 15 are both below and to the left. Those are corresponding. I use an angle sign this time. 8 and 13. 8, 13, connected by this line going up and down. So I can eliminate this half. Okay, I can just put my hand over it. 8, 13, both inside, alternate sides, alternate interior angles, AIA. 1 and 12. 1 and 12. This is the line connecting them, so there's a relationship. 1 and 12 are both outside, alternate exterior angles for 1 and 12. 4 and 7. Here's the line connecting them, going straight across, so I could eliminate the bottom. 4 and 7 are both inside, and they're on the same side. So those are same side interior angles. 3 and 1. 3, 1, same cluster, linear pair, supplementary. And 10 and 7, there's no line connecting angles 10 and 7. If there's no line that connects angles 10 and 7, there is not a relationship. Because there is not a transversal. So these are not alternate interior angles. Yes, I do agree they're both on the inside. However, there's no transversal connecting them, so there's no relationship between 10 and 7. All right, that video got a little bit long. Sorry about that. Have a great rest of the day.